Welcome everyone for today's class. In today's class, we are going to discuss about co-precipitation and post-precipitation. Before that, we need to revise what are the things we have discussed in gravimetric analysis, because co-precipitation and the post-precipitation arises in gravimetric analysis only. So we need to see some of the basic things already we have discussed in the previous classes. What is gravimetric analysis? Gravimetric analysis is the quantitative determination of analyte concentration through a process of precipitation of the analyte and the isolation of precipitate and weighing the isolated product. For example, here we have we are going to, if we want to estimate the chloride ion, we are using a precipitant silver nitrate. Silver nitrate is precipitated as silver chloride. This silver chloride precipitate is weighed and isolated and weighed, and from that silver chloride precipitate we are going to estimate the chloride ion. So these are the procedures we are following in gravimetric analysis. First, we are weighing the sample, that is weighing the sample, and then we are coming into adding the precipitating agent, and then heating, that is in the digestion. After that we are going to the filtering and heating and filtering, and then we are weighing the precipitate. In gravimetric analysis we have to follow these are the major things. They are a weighed sample is dissolved, that is it should be in the diluted form, and then an excess of precipitating agent is added to the solution. So if you add the excess of precipitating agent in the solution, the the substance or an ion which we are going to estimate will be get precipitated completely. So that we have to do this, we have to um, add excess of precipitating agent in the solution. And then the third one is the resulting precipitate is filtered and then dried and heated. That is, for drying, we are drying is done in the oven or muffled furnace, like the muffled furnaces, and then weighed. After that, after weighing that, we have the mass of the precipitate. From the mass of the precipitate, we have to um, find, or from the known composition of the precipitate, the amount of the original um, ion or the substance will be found. Then the types of crucible. While we are doing gravimetric analysis, we are using different types of crucibles. Um, they are they are mainly two types. Um, uh, uh, they are silica crucible and sintered crucible. These crucibles, made up of porcelain or silica, are used when the precipitate are dried in an oven or the muffle furnace. Um, Oven or in the muffle furnace. If we are using the sintered crucible, are used for the precipitate which are weighed after drying in air oven. So these are the crucibles we are using in gravimetric analysis: silica crucible and porcelain crucible and sintered crucible. Then we come into the main topic of today: co-precipitation and post-precipitations. What is co-precipitation and what is post-precipitation? So the degree of these are the um, the degree of contamination in gravimetric process, that they are co-precipitation and post-precipitation. Co-precipitation means the soluble impurities which are getting precipitated along with the formation of the precipitate. If it is the post-precipitation, after the formation of the precipitate, the impurities will get soluble. So this is called co-precipitation and post-precipitation. We will discuss detailedly. In post-precipitation, for example, here we are given the calcium is precipitated as calcium oxalate. In post-precipitation, when calcium is determined as its oxalate or any magnesium, if there is a presence of an impurity, the magnesium is present as an impurity. So this magnesium gets dissolved in the solution, but it is not dissolving the solution. If it is not dissolving in the solution, it is also gets precipitated as magnesium um, magnesium oxalate. So that, so if you are going to calculate the weight of the calcium oxalate, but if the magnesium is precipitated, including with this, the amount of the precipitate gets increased. So the post precipitation can be avoided by keeping a high pH. So in this reaction, the calcium is estimated using the oxalate, but if there is any presence of any magnesium, the solution will be precipitated in this. I mean, magnesium is precipitated in the solution, and similarly, when the copper 2 plus also, or uh, mercury also um, precipitated like this. This type of post precipitation occurs with sparingly soluble substance which form supersaturated solution. That is super saturated solution. So due to the formation of supersaturated solution, only the post precipitation occurs. These substances usually have an ion on common with the analyte. For example, uh, if you take in the post precipitation of magnesium oxalate, here the formation of the magnesium oxalate is the post. Forming as a post precipitant precipitation. So while estimating calcium by precipitating it as the calcium oxalate. So how can we avoid this post precipitation, or so what are the remedies to decrease the post precipitations? We have two remedies or two methods to avoid uh, the post precipitations. They are: the precipitate is washed with soluble, suitable solution so as to remove the post precipitated impurity. So here, if we wash properly the suitable by using suitable solution, so that there must not be the formation of magnesium oxalate. So we can avoid the formation of magnesium oxalate when we do uh, dissolving in suitable solution, or washing in suitable solution. And another one we can do that the precipitate should be filtered off as soon as the precipitation is over. So we need to filter the precipitate soon after the precipitation is over. After digestion, if the precipitation is, I mean, it is over, soon after we have to filter the precipitate. Otherwise, there is the possibility of the formation of post precipitation. That is like calcium oxalate. So we have to um, filter off as soon as the precipitation is over. So these are the two things, two remedies to avoid post precipitations. So they are the precipitation washed with suitable solution, and we have to filter the precipitate soon after the precipitation is over. And then we have the co-precipitation. What is a co-precipitation? Here we have given an example for co-precipitation, and also we know that the co-precipitation is a process by which the normally soluble components of a solution are carried. That is, soluble components also combined with uh, during the precipitation. If there are the presence of some ions in the solution, that ions also uh, uh, combined for the formation of the precipitate. So we need to avoid this. So we'll see how to avoid the this co-precipitation. Now we'll see what is co-precipitation with an example. Here I have given an example, that is barium is precipitated, estimated as barium sulfate. So in this, in the determination of barium ions by precipitation as barium sulfate, other barium salts such as barium nitrate and barium chloride so occluded on barium sulfate precipitate. So if it occludes, so that is also included with the precipitate. And also we know that the barium nitrate and the barium chloride are soluble in the solution. But during the precipitation of barium sulfate, the soluble compounds occluded or occlude on barium sulfate particles. It combines with the barium sulfate particles. So these are carried down also with the barium sulfate precipitate, such as this co-precipitation occurs. So along with the formation of the barium sulfate, there is a formation of some barium nitrate, also barium nitrate, as well as barium chloride also forming. So these also combined with the amount of or the weight of barium sulfate. So this is called the co-precipitation. So this co-precipitation of the precipitate is occurred due to the dissolved ions. So that we can define the co-precipitation again like this. So the this is the contamination of precipitate by a second substance, which is also precipitated along with the substance to be precipitated, does not constitute co-precipitation. So the theory behind the co-precipitation, so we can say that what happens during the co-precipitation, why the dissolved ions also getting precipitated. The co-precipitation occurs either by, so this co-precipitation occurs either by the surface adsorption or inclusion or occlusion. So co-precipitation occurs due to surface adsorption, inclusion or occlusions. So if it is the formation of the gelatinous precipitate, if the formation of the gelatinous precipitate by the gelatinous precipitate is co-precipitated by adsorption, whereas if the formation of the precipitate is crystalline, the co-precipitate is occurred by inclusion or occlusion. So we know that if the gelatinous precipitate is forming due to the adsorption means it is a surface phenomena. It is occluded it is absorbed on the surface of the substance or surface of the solid. Inclusion involves the random distribution of the contaminant throughout the interior of the solid. But and the occlusion, which means which occlusion involves a non-homogeneous distribution of the contaminant within the imperfection in the crystal lattice of the precipitate. Therefore, co-precipitation occurs due to this process: surface adsorption, inclusion, or occlusion. depends on whether the formation is a gelatinous precipitate or the crystalline precipitate. So it has some of the. Before that, we have to see that um, here the post precipitation is occurred due to the formation of barium chromate. Here, barium chromate is forming in addition to the formation of barium sulfate. So, this will added with this and gives uh, the higher amount of the precipitate. If the precipitate the formation is increases with addition with the other ion, then there is the increasing of the precipitate, which will give the wrong amount calculations. So the contaminant will go and get occluded inside the crystal lattice of barium sulfate. Here, this contaminant go and add with I mean barium sulfate. And also co-precipitation can cause erroneous result. I mean, which means the wrong result it gives. So we need to avoid the post precipitation. And also some disadvantages of the post precipitation is or disadvantages or some effect of co-precipitation which gives in the gravimetric analysis is, so because of co-precipitation, positive or negative error may result, whether the amount of the precipitate may increases or decreases, as well as and also um, the substance has more or less molecular weight. So if due to this substance gets the molecular weight be more or less molecular weight than that of the precipitate if you are expected. Uh, for example, during the precipitation of the year I have given the during the precipitation of this barium sulfate, if barium nitrate is precipitated, uh, positive error is observed. As barium nitrate or barium chromate is precipitated, positive error is occurred. It is observed in the molecular weight of barium nitrate is more than that of the barium sulfate. So on the other hand, if the barium chloride is co-precipitated, if there are two things are forming, not only the barium chromate, it also the formation of barium nitrate and also barium chloride are forming. So that this barium nitrate increases the precipitate weight. If it is the barium chloride is co-precipitated in the uh, during analysis, a negative error is occurred as the molecular weight of the barium chloride is less than that of the barium chloride is less than that of barium sulfate. So that it gives the negative error, that is weight gets lost. So we need to due to the co-precipitation, we'll get the wrong amount or the estimation gets um, um, wrong, gets the unwanted amount of the precipitate. So that we need to avoid this. How can we avoid the co-precipitation? Simply we can say, if you say this means not to minimize this co-precipitation, we digest the precipitate. So we need to digest the precipitate. If we digest the precipitate means we can minimize the co-precipitation. So and then digesting the precipitate in suitable solvent and reprecipitation gives good yield. So if it occurred means we should go for reprecipitation only. So if we go for the reprecipitation only, the way to find the correct amount of the substance is going to be estimated will be occurred. In addition to this, we'll see some methods to decrease or minimize co-precipitations. We have what are the things we can do is, and the first one is to the solution from which the precipitate is carried out should be diluted. If we in the great dilution, so the co-precipitation gets minimized. And then the second one, the precipitant is to be added in small quantities with constant stirring. The second one, so we need to add the small quantities with constant stirring. If we do that, there is uh, co-precipitation decreases, so that the precipitation takes place slowly. If the slow precipitation, that is a formation of the crystal, is slowly, if it is formed slowly, the crystal form the bigger sizes, so that when we filter it means we can filtration also easier one. Then the third one is the precipitation is carried out from hot solution only. So if you are cutting, so that the solubility of the impurity would be increased, and also the formation of colloidal particles would be decreased. So the solubility increased, solubility of the impurity increased. If it increases means it will not included with the precipitation. And the colloidal particle formation also decrease. If it decreases, then there is an increasing of the accuracy, and the attraction between precipitate and impurity would be decreased. So these are all happening where solubility of the impurity increased, colloidal particles decreased, formation of colloidal particle decreased, and attraction between the precipitate and impurity would be decreased. So when we do um, the precipitation in hot condition, and then the fourth one is the precipitate is digested well. So when we digesting during the precipitation, these methods would decrease co-precipitation due to surface adsorption. So, so it decreases the co-precipitation due to surface adsorption. So the particles go and adsorb on the surface, so that it decreases the co-precipitation. Then the fifth one is the precipitate is dried at high temperature. So we need to dry the precipitate at high temperature. If you are drying the precipitate at a higher temperature, so that the occluded impurity could be escaped. So the precipitate occluded on the surface of the precipitate is going to be estimated will be gets escaped. And then the sixth one is solution employed in precipitation are well diluted. So the solution should be in very well dilution. So if it is in the highly diluted form, so that when the mother liquor adheres to the precipitate, there is no much solute in it. So this will decreases occlusion. Occlusion also avoided if you do the precipitation in dilute condition. And then the crystal growth must be slowly. When if you do this, the crystal growth must be slow, so that occlusion will be less. So the occlusion will be less when we do the when if the crystal growth is slow. So these are all the several methods to decrease or minimize the co-precipitation. Here we have these are the points we have to follow to decrease the co-precipitations. In addition to this, so we already know that what is gravimetric factor, that is the mass of the substance to be the substance is to be estimated, the ratio between the mass of the substance to be estimated and the molecular mass of the substance formed. This is so in this here we have the when we are going to estimate the silver ion is precipitated as um, sorry, when you are going to precipitate chloride ion, the chloride ion is precipitated as silver chloride. So there's a molecular mass of silver chloride in the denominator, and the substance is going to be estimated as in the numerator. So here in this, if we have the gravimetric factor of this is, we know the mass of the chloride, that is 35.5, and the mass of silver chloride is 143.3. So which gives the factor, um, so more than 2, more than 0.24. Likewise, if we find the gravimetric factor for the estimation of calcium, determination of, when we are determining the gravimetric factor of calcium in water, if you precipitate calcium as calcium carbonate. So if you are going to determine the calcium by precipitating calcium as calcium carbonate, so here in the numerator it comes the the mass of the substance is to be estimated is the calcium ion, and uh, the mass of the precipitate formed, the molecular mass of the substance which is precipitated in the analysis. So for this we know the mass of the calcium is 40 and molecular mass of calcium carbonate is 100, so it gets the gravimetric factor 0.4. And then some of the factors which affect the solubility of precipitate. During the precipitation, some of the factors affecting the solubility of the precipitate, they are temperature, solvent composition, that is concentration, and diverse ion effect. So these are the three factors: temperature, solvent composition, and diverse ion effect are causing the factors which affect the solubility of the precipitate. So how it affects is, so in the temperature, heat is absorbed as most solids is dissolved. Therefore, the solubility of precipitates increased with increasing temperature. And if at higher temperature, the precipitation gets increased. When if at the solvent composition, the nature of the solvent influences the solubility of most inorganic substances. That is, for the most inorganic substances, the solubility increases, and also the formation of the precipitate increases. And diverse ion effect. Many slightly soluble salts show an increased solubility in the presence of increased concentration of certain salts. So in the certain salt, when we are increasing the concentration, that is increasing of the precipitation having no ion in common with those of the slightly. So like the ions, if you are having the chloride ion, like chloride ion, such chloride ions are not given by other substances present in the solution, so that the precipitation as occurs clearly. In this lecture, we have discussed what is gravimetry, mainly about the co-precipitation and post-precipitation. In addition to that, we saw what is gravimetric analysis and how we are doing measuring the or estimating the substance, and then what are the things that have to be followed in gravimetric analysis, and what are the crucibles we are using in uh, the gravimetric analysis, visa, and then we discussed in detail about co-precipitation and post-precipitation, and with examples, and gravimetric factor, how to calculate the gravimetric factor of the gravimetric analysis. I hope you understood. Thank you.